Okay, guys, yesterday we discussed about how to create a thread. One way of creating thread is what external thread class. Other way of creating a thread is what by implementing runnable interface. Two ways are there. Then if you ask me, then which is the better approach for me? Is extending thread class is a better approach or implementing runnable interface is a better approach? If it is a question, the answer for this question is what implementing runnable interface is a better approach. Why implementing runnable interface is a better approach? Because if I extend thread class for creating a thread, then I cannot extend any other class. Because in Java, one class can extend only one superclass or one parent class. A class can extend only one parent class. Suppose if I want to extend another parent class, I don't have that option because of already I'm extending thread class. Because of I'm extending already thread class, right? But whereas if I'm implementing runnable interface, then I have options. I can even extend another class by implementing runnable interface. That's why implementing runnable is a better approach when compared with what extending thread class. Okay, implementing runnable is a better approach when compared with extending thread class. Because a class can extend another base class also. Yet the class can extend another base class also. But here it is not possible because already it is extended thread class. That's why it cannot implement any other, it cannot extend any other super class. That's why this is not the good approach, but this is a good approach. Okay. So that's the answer to say. That is the answer to say. If suppose somebody asks about which is the good approach, like extending thread class or implementing runnable. Correct? Let me tell you. Observe. See, the question will be this totally multi-threading document. I'm not giving any date or something, just write like one document. Okay. The question is, so which way of creating a thread is a good approach? Is a good approach. Answer is okay. Answer is implementing runnable interface. Because thread class can also extend another super class or parent class if we implement runnable interface. If we implement runnable interface. Implementing runnable interface is a better approach because a thread class can extend another parent class if you implement runnable interface. Okay. Next. Look at this. Now, let's see. We will discuss this example. This example is by extending thread class. Next example, we will see by implementing a runnable interface. This is using Java 8. Okay. Look at this now. In the same example, first thread I am creating by extending thread class, which prints numbers 1 to 10. The second thread, I want to implement runnable interface. Implements runnable. Okay, if you look at the two classes, one is I'm creating a thread class by extending thread. The second one is I'm creating a thread class by implementing runnable. My first thread prints values 1 to 10. The second thread prints values 11 to 20. Whatever the task that you want to execute in a thread, that the task we should define in run method. In both the ways, while creating a thread, either this way or this way, we have to override this method. Which method? Run method. Either in this way, extending thread class, or by implementing runnable, we have to override run method only. Okay, and here we have to define the task. Here the task is display the values 1 to 10 and display the values for every 2 seconds. Here also same thing, display the values for every 2 seconds. Okay, this if I call the sleep method, then this thread will go to sleep mode for 2 seconds. So other thread will get the chance. Then we can understand that both the threads are executing. Simultaneously. If I don't give sleep, then to print 1 to 10, system doesn't take more than 1 millisecond. It doesn't take more than 1 milliseconds. But while executing a thread, it will get approximately 100 milliseconds on the CPU port. So what happens in this case now, 1 to 10 will be immediately printed. Then you will not get a feeling that the two threads are executing parallelly. That's why we are providing some sleep time so that we can able to see that the two threads are executing parallelly. To show you the output like this, we are just keeping the sleep time. Okay, this thread will print values from 1 to 10. This thread will print values from 11 to 20. The first thread will print values from 1 to 10, second thread will print values from 1 to 20, 11 to 20. It implements runnable, it extends thread, two ways of creating. But if you implement runnable, directly we cannot call start method. So you are getting an error at line number 41. Because this class implements runnable. If a class implements runnable, it doesn't have a start method. Because runnable interface contains only one abstract method, that is called run method. It doesn't have any start method or it doesn't have any other methods. It doesn't have a start method. That's why we are getting an error. So if you create a thread by implementing runnable interface, again to start the thread, we need to wrap the runnable object into thread object, which means we have to write the code like this. See, we have to write the code like this. Thread T2 equal to new thread of new my thread 2. This is the code. What I am doing here, a runnable object, this is runnable object. This class implements runnable, so we call it as a runnable object. Runnable object doesn't have start method. So we need to wrap the runnable object into thread object. You need to wrap the runnable object in a thread object, then you can start. But directly you cannot start runnable object because runnable doesn't contain start method. Because the runnable doesn't contain start method. So what's the point I want to write here? Wrapping runnable object into a thread object. Why we are wrapping? Point is we are wrapping because runnable object doesn't have start method. Because runnable object doesn't have start method. I'll write in the next line. Doesn't have a start method. That's why I'm doing like this. Okay, this is how I need to execute my code. Now you can see the two threads are executing. One thread is printing the I value, other thread is printing the J value. You are getting I value, J value, I value, J value like this. The two threads are executing parallelly. One thread is displaying the value of I, other thread is displaying the value of J. Okay, the two threads are executing parallelly. This is a way of creating threads in Java. Okay, if you have any task which you want to execute independently, okay, then you have to define a thread. You create a thread for the task. If you have another independent task, create one more thread. Like this, you can create multiple threads. It is called multi-threading. And all the threads can execute parallelly so that we can utilize the maximum CPU cores. Okay. If you don't create threads like this, then what happens? You can able to see only one CPU core is utilized. Execution takes more time. Correct. That's why we are creating multiple threads in application. One application can have multiple threads and each thread can do a task and we can execute multiple tasks parallelly with the concept or with the use of multi-threading mechanism. Okay, are you getting my point? Next, I'll answer your question, then I'll answer your question. Okay, next. This is okay. An example for you to practice. Same example of last class, but there is a small change in the code. There is a small change in the code. What's the change in the code? I just want to say. The small change in the code is there, but the change in the code. If we implement okay, if we create a thread by implementing runnable interface. If we create a thread by implementing runnable interface, then we can't start the thread. We can't start the thread because it doesn't have a start method. It doesn't have start method. It doesn't have start method. If we create a thread by implementing a runnable interface, then we can't start the thread because it doesn't have start method. Correct? It doesn't have start method. Correct. Then what to do? So we need to wrap the runnable object into a thread object so that we can start the thread. We can start the thread. Example. Example is this one. This example, go through it. Now coming to the point. Next question. So actually start method belongs to threads, which will start the thread. Today we are going to see the life cycle, thread life cycle. Today we are going to see the thread life cycle. I'll explain the thread life cycle today. That is a main concept. But before I explain about the thread life cycle, before I explain about the thread life cycle, I want to call the start method. For example, already T1.start means thread is started. If I say again T1.start, if I start the same thread multiple times, then I will get an exception. Let's see the output here. Okay, you got an exception called illegal thread state exception. You will get illegal thread state exception. Illegal thread state exception. So the point is what? The point is what? We cannot start the thread 2 times. If you start the thread, if you start the thread 2 times, then you'll be getting an exception called as illegal thread state exception. Okay, and you will not get any multi-threading here. Only one thread will be executed, second thread will not be executed. Second thread will not be executed. Only one thread will be executed to print 1 to 10, but you are not getting J value, only I value you are getting. That's why we cannot start the thread twice. We can start the thread only one time. If you start the thread twice, 2 times, multiple times, then what happens? You will be getting exception. That is called illegal thread state exception. Illegal thread state exception. Okay, cool. See here. The question is, if we start a thread for 2 times, what happens? If you start a thread for 2 times, what happens? Answer, let's say T1.start, again T1.start. Okay, like this, if you start the thread twice, 2 times, what happens? Answer, you will get illegal thread state exception at runtime. Illegal thread state exception at runtime. That's answer for this question. Next. Instead of calling start method, the process is first you call the start method. Then you'll see the life cycle. Suppose if you directly call the run method, we can directly call run method. Now, okay, this question is over. Now, for example, I'm writing T1.run, not T1.start, T1.run. I'm calling run method directly. I'm calling the run method directly, not the start method. I'm calling the run method. Let us run this program. Now, we won't get any error or exception. We won't get any error or exception. Directly, I can call the run method. If I directly call run method, you can see you are not getting the 2 threads executing parallelly. If you directly call the run method, only one thread will execute at a time. Again, this is going to become sequential execution. After I value is completed, I is printed 1 to 10, next J started from 11. J started from 11. J is from second thread, I is from first thread. The two threads are not executing parallelly. The 2 threads are executing sequentially, one after the other. Then it is not called a multi-threading. Then it is not called a multi-threading. Correct. It is not called a multi-threading. So what happens if I directly call the run method? This is the answer for your question, Dan. Dan, you asked a question. This is the answer for your question. Okay. Cool. Let me write a question. Can we call run method directly without start? Answer is yes, we can. Yes, we can call, but the threads will Yes, okay, we can call, but the threads will execute sequentially. Threads will execute sequentially, but not parallelly or concurrently. But not concurrently. The threads will execute sequentially, but not concurrently. That's the answer for this question. Okay. Right. This is all questions which are related to our first program in multi-threading. Okay. Within one application, we can create multiple threads for multiple tasks and we can run them parallelly. That is called multi-thread. This is T1 dot start. This is T2 dot start. Now the threads will execute parallelly. Now the threads will execute parallelly. I and J both are executing parallelly. The two threads are executing parallelly. This is how we are calling it as multi-threading. This concept name is called as multi-threading. This concept name is called as multi-threading. Right. Okay, this is all about this first program. Creating threads by extending thread class by implementing runnable interface. Okay, right. Now we need to understand about the concept called as thread lifecycle. So in thread lifecycle, we have different stages. The lifecycle represents since from the thread is created until that the thread is died. It will go into different stages. Okay, the thread object from its creation to termination, the thread will go into multiple stages. That is called lifecycle. Better, I will write the definition of what is lifecycle. A thread's lifecycle. A thread's lifecycle is nothing but since from object creation, until it is terminated or until it is removed, until it is terminated, a thread will move into different stages. Different phases or stages, anyway. Move into different stages. It is termed as life cycle. It is termed as life cycle. It is termed as life cycle. A thread will move into different stages. It is termed as life cycle. Okay. Now we'll understand about who is life cycle. Okay. Now I will give you the diagram completely in one example, but first I want to explain about what are the different stages in the life cycle. So the life cycle stages. The life cycle stages are, first stage is called newborn stage. The second stage is called runnable stage. Third is called running stage. Next one is called a non-runnable stage. Last one is called dead stage. These are the life cycle stages. First one is called a newborn stage, then called runnable stage, then called running stage, then called a non-runnable stage, and finally it is called dead stage. These are the different stages in the life cycle of a thread. Let's see. Let's see the diagram for this. See, whenever we create a new thread object, for example, this is the new thread created. Whenever a thread object is created, it will enter into a stage which is called as whenever we create a thread object, a thread will enter into a stage which is called as newborn stage. It is called as newborn stage. Whenever a new thread is created, it will be in newborn stage. I mean to say that you are creating the thread object, but you are not calling the start method, which is called as newborn stage. Let me give you. Okay, let me give you. For example, I'm creating like this. My thread T1 is equal to new my thread. This is called a newborn stage. This is called a newborn stage. Nothing but you are created the thread object, but you have not called a start method. Just only object is created. If a thread object is created and you didn't call start method, you have not yet called the start method. Then we call it as newborn stage. Now this is in a stage called as newborn stage. This is in a stage called as newborn stage. But whenever you call start method, the thread will be moved into runnable stage. For example, if I say T1 dot start now, T1 dot start. Now the thread is moved to runnable stage. When you create the object, it is in born stage. It's born stage. Okay, that's what newborn. But whenever you call start method, it will enter into runnable stage. Stage or state, anything. The thread will enter into runnable stage or runnable state. The thread will enter into runnable stage. Like this, multiple threads can enter into runnable stage. For example, if I have next thread, my thread 2, T2 is equal to new my thread 2. New my thread 2, which is nothing but this thread is in newborn stage. But whenever I call T2 dot start, it will enter into what? Runnable stage. Now tell me, if I write T1 dot start and T2 dot start, we can say that two threads entered into runnable stage, which means multiple threads can enter into runnable stage. Multiple threads can enter into runnable stage at a time. If I say T1 dot start, if I say T2 dot start, if I say T3 dot start, if I say T4 dot start, for example, I have 4 threads. Now T1, T2, T3, T4, all these 4 can enter into runnable stage. So when you call the start method, the thread will enter into runnable stage. So the next stage is called runnable stage. So from newborn, the thread will enter into runnable stage. Let's say, for example, this is called runnable stage. I want to write my diagram like this now. This is called runnable stage. I call it as a runnable stage. Is the runnable stage. So to move a thread from newborn to runnable stage, we are calling a method called as start method. We are calling a method called as start method. The start method will move the thread into runnable stage. We are calling a method called as start method. Start method will move the thread into runnable stage. Okay, we'll move the thread into runnable stage. There is a start method. Now, multiple threads can enter into runnable stage. Multiple threads can enter into runnable stage. Yeah. Multiple threads. Multiple threads can enter into runnable stage. But only one thread can enter into running stage. For example, there are threads like T1, T2, T3, T4 are in the runnable stage. But all the threads will not get the chance at a time to enter into running stage. Only one thread can enter into running stage at a time. Only one thread can enter into running stage. From runnable to running. One will be picked up. For example, if 4 threads are in runnable, one will be picked up. It may be T1 or T2 or T3 or T4. One thread will be picked up. How it is picked up? With the help of who will pick up? Scheduler. There is a person called as thread scheduler given by operating system. There is a thread scheduler. There is a thread scheduler. Right? So this thread scheduler is a person. It will pick up one out of them. Out of these 1, 2, 3, 4, it will pick up one by following some algorithm, like a round robin algorithm, preemptive algorithm. Based on some scheduling algorithm, this scheduler will pick up one thread out of multiple and will move the thread into running stage. This person is the responsible person for picking up one thread from runnable stage and moves it into running stage. So the next one is running stage. I will write the points later, but first I want to complete the diagram. Now the thread is moved from runnable stage to running stage. The thread is moved from runnable stage to running stage. A thread is moved from runnable stage to running stage. Move to running stage. Now, next point. Who will pick up means scheduler. Only one thread will be moved into running, remaining are still in runnable only. From running stage, if for example, any sleep method is called on the thread, if any sleep method is called on the thread, or if wait method is called, if a sleep method is called on the thread, right, or if a wait method is called on the thread will go into non-runnable stage. The thread will go into non-runnable stage whenever sleep method is called or wait method is called. I want to make sure that there is a stage called as non-runnable stage. For example, I'm giving non-runnable stage like this. I'm just making like a box. This is called a non-runnable. This is non-runnable stage. When thread will go to non-runnable stage from running stage, a thread will be moved from running stage to non-runnable stage when sleep method is called. Sleep method called means thread will go to sleep for some time. Thread will go to sleep for some time. Let's say, for example, I'm writing inside this sleeping. Sleeping comes under non-runnable. Sleeping. From where it is moved from running stage to sleeping stage. When the sleep method is called. When the sleep method is called. Sleeping comes under non-runnable. Once the sleeping time is over, a thread will be moved from sleeping stage back to runnable stage. Will be moved from, once the sleeping time is over, it will be moved back to runnable, not directly running. First it goes to runnable only. Always thread will enter into running from runnable only. So it will go to runnable. Again, from there, it will go to running later. The thread will move like this. Another way is, we'll also call wait method. We'll also call, for example, this is called waiting. For example, I'll make it as waiting. I'm writing it as waiting. Waiting. Waiting stage also called as sleeping, waiting. Both are having a difference that you'll know later. But currently, what I'm saying is, okay, when wait method is called, a thread will be moved to waiting stage. A thread will be moved to waiting stage when wait method is called. When wait method is called, a thread will move to waiting stage. And again, from waiting stage, when notify method is called, it will be moved to runnable stage. So from running, a thread can go to non-runnable stage like sleeping or waiting. If it enters into sleeping or waiting, these two comes under non-runnable. Again, after that waiting is over or sleeping is over, it will go to runnable. A thread will enter into runnable again. Okay, right? A thread will enter into runnable again. Again, from runnable, it will go to running. When we call yield method, when yield method is called, yield method means when the time is over, it can enter into runnable directly also. It can enter into runnable directly also. It can enter into runnable directly also. For example, when a thread is coming to running, it will have some time limit, time slice. Scheduler will provide some time. Suppose if a thread execution takes half an hour, it cannot be there in running for half an hour. There may be approximately 100 milliseconds time will be given. After that time is over, the thread will be moved back to runnable, from running to runnable directly. If there is no sleep called, if there is no waiting is called, then it will be moved from running to runnable again when the time is over. Because other threads are in runnable, they are also waiting for the chance. That's why when the sleep time is, when the time slice is over, nothing but for each thread, some time is allocated. After that, a time allocation is happened, the thread will be moved back to runnable. If any sleep is called, then it will go to sleeping state. If any wait is called, it will go to waiting stage. But if no sleep is called, no waiting is called, then the thread will not be there for a half an hour in the running state. It will be there for some time limit, maximum time limit. Once its time slice is over, it will go to running stage. Sorry, it is going to runnable stage from running. When time slice is over, here is what when wait method is called. Here I will write when wait method is called. This is when wait method is called. Now here is what when time is over. Time slice means time is over. When time is elapsed. I will add the point here when time elapsed. I'll use different. Yeah. When time elapsed. When time is lapsed. When time is lapsed. Time lapsed means time is over. When time is lapsed, it will enter into runnable stage. Now, all these stages will execute in JVM. is runnable stage, running stage, non-runnable stage. All these stages will be there for a thread when the thread is in JVM. Okay, when the thread is in JVM, all these stages will happen. All these stages will happen when the thread is in JVM. When the thread is in JVM, all these stages will happen. All these stages will happen. And when the thread, okay, when the thread execution is completed, when the thread's execution is completed, then the thread will enter into dead stage. For example, the execution of a thread is completed. Its execution is over. So when a thread's execution is completed, the thread will enter into dead state. So from running, the thread can enter into dead state. A thread can enter into dead state. I am writing here dead state. I'll use a different color. Now this is the life cycle. This is called a dead state. This is called dead state. This is actually called as a dead state. This is called dead state. Now this is actually called as thread life cycle diagram. Let's see the states now. Thread is newborn state. When a call start method enters into runnable stage, multiple threads can enter into runnable. But all the threads can at a time, all the threads cannot go at a time into running stage. Only one thread can go. That who will pick up that one thread is scheduler. Who will pick up that one thread is scheduler will pick up, thread scheduler. That one thread will go to running. When the thread is executing in the running stage, run method is called. In the running stage, run method is called. Run method is executing the running stage only. Now what happens? In the running stage, if a sleep method is called, the thread will go to sleeping state. If a thread goes to sleeping state, other thread can enter into running state. If a thread goes to sleeping state, other thread can enter into running state. Once the sleeping is over, time is over, like 2 seconds or 5 seconds or 10 seconds, then it will go back to runnable again. Okay. When a one thread goes to sleeping, then other thread will get the chance to enter into running. Or when one thread goes to waiting, then other thread will get the chance to enter into running. For example, a thread is not having sleep or waiting. Then it's when the time is elapsed. The thread cannot be there in the running stage forever. For every thread, some time limit will be there. After the time is over, it will be sent back to runnable so that other thread will enter into running. Like these threads will orchestrate. Okay, if there is sleep called, obviously it goes to sleeping stage. Then other thread will get the chance. But if no sleep is called, no wait is called, then the thread cannot be there in the running stage forever until it is completed. There is a time limit will be there for every thread. When the time is elapsed, then the thread will be moved to what again? Runnable stage. Okay, other thread will get the chance to enter into what? Running stage. Like this. And once the thread execution is completed, the thread will go to which stage? Dead stage. So these are the different states. Now one is called newborn stage, runnable stage, running stage, non-runnable stage, and dead stage. These are the different stages in the life cycle of a thread. Let's have this diagram, then I'll write the points. I want to write this first. Okay, I first want to add this diagram picture into our document, and then I will write points on this document diagram. So if you look at this is a diagram. Now this is actually called as life cycle of a thread. But here we need to add some points related to the life cycle. So first point is what? Whenever a new new thread object is created. Whenever a new thread object is created, then a thread enters into new bound state. Whenever a new thread object is created, then a thread enters into new bound state. That's the first stage. When start method is called, a thread will be moved from newborn state to runnable stage. When start method is called, a thread is moved to the runnable stage. Okay, when start method is called, a thread is moved to the runnable stage. Multiple threads can be moved to runnable stage at a time. Multiple threads can exist. Multiple threads can exist or can be moved to runnable stage. Multiple threads can be moved to runnable stage by calling start method. For example, T1 dot start, T2 dot start, T3 dot start. What happens now? T1, T2, T3, all these three threads will be moved to runnable stage. Multiple threads can be moved to runnable stage, but only one thread can enter into running stage. From runnable stage, a thread scheduler will pick up one thread and moves it into running stage. Only one thread can enter into running stage at a time. At a time, only one thread can enter into running stage. Multiple threads cannot enter, only one can enter into running stage. When a thread are in running stage, run method is called. In a running stage, run method will be executed. Okay, next. In run method, if sleep or wait method is called. In run method, if sleep or wait method is called, then a thread enters into non-runnable stage. Then a thread enters into non-runnable stage. Next, when sleep time is over, or when notify is a method we'll discuss later. When sleep time is over or when notify method is called, then a thread will be moved to runnable stage again. A thread will be moved to runnable stage from non-runnable stage. I'll add this statement also better. From non-runnable stage. Next. Suppose no sleep or wait method is called. No sleep or wait method is called in run method. No sleep or wait method is called. No sleeping, no waiting for the thread. But thread will not be there for long time. In this case, the scheduler will move the thread into runnable stage once the time is completed or lapsed. Once the time is lapsed. For every thread, scheduler will allocate a time slice, a piece of time. Will allocate a piece of time. And a thread can run maximum up to that piece of time. Up to that piece of time. A thread can run maximum up to that piece of time. After that, it is moved back to what stage? Runnable stage. That's what time slice. Okay, for example, if a thread execution takes totally half an hour time, a thread cannot be there half an hour in the running stage. Because if one thread is running in half an hour, what about other threads T2, T3, T4? They are all still waiting in the runnable. That's why there is a time slice is provided. So after 100 milliseconds, for example, automatically this thread will be moved back to runnable. Another thread will be taken into running. Like the two threads are executing parallelly. This is called multi-threading. Okay, that's how it works. Okay, right. So last stage is called dead stage. Obviously, once a thread execution is completed, the thread will be moved to dead stage. The thread goes to dead state. This is called life cycle. These are all the statements which are related to the life cycle of a thread. These are the different stages in the life cycle. These are all called different life cycle stages. One is newborn stage, next one is runnable stage, next one is running stage, next one is non-runnable stage, and last step is called dead stage. These are the different stages in the life cycle of a thread. Okay, right. Good, cool. Now we'll discuss about some of the methods which are there in thread class and what is the thread priority. We are going to understand all these things. I'll explain. There are different methods in thread class. All the methods are not required, but still I will show you the methods first. There is a class called thread. There is a class called thread. This thread class implements runnable interface only. I told we can also create a thread by implementing directly runnable interface. It contains only one abstract method, that is run method. Only run method. Okay. Okay. I'll tell once again. Runnable interface contains only one abstract method, that is called run method. That is the reason why runnable is called as functional interface. Function interface means it contains only one abstract method, that is called functional. It contains only one abstract method, that method name is run. Okay. Thread class also implements runnable interface. Okay. But still, whenever we are creating a thread by extending thread class, we must override run method only. But still, we must override run method only. Even though the thread class implements runnable interface, but when we are creating a thread class by extending thread, then we have to override run method only, because start method internally calls run method. When a thread is in running state, I told which method is executed is run method. which means in every thread, whether you are creating extending thread class or implementing runnable interface, that must contain run method. Because in the running stage, run method only called. When a thread enters into running stage, which method is executed is run method, which means every thread must contain run method. Either you are extending thread class or whether you are implementing runnable interface, it doesn't matter. Okay, cool. When you come to methods, I'll talk about priority next. Okay. Okay. I'll talk about thread class methods. So there are many methods. Out of them, many methods are deprecated. You can say deprecated means they are not in use now. Every thread contains an ID. There is a method called as get ID. Every thread contains a name. I'll tell you, get name. Every thread contains a priority, get priority. If you want to know the current state of a thread, then get state is a method. Thread groups will discuss later. If you want to check whether thread is live or not, he is alive. I'll tell you what is daemon thread. If you want to check whether a thread is daemon thread or not, he is daemon. And if you want to, join one thread with other thread, join is a method. We are going to see the join statement also. And of course, run method is the main method. Run, set daemon, set name, set priority, sleep. Sleep is a static method. Static method can be called directly with the class name, thread.sleep, because static method. If a method is static method, we can call the method directly with the class name. That's what static method, sleep. Start is a method, just now we discussed. Stop method is deprecated. There is no stop method, suspend method, these are removed now. Okay, there is a method called as yield. Yield is also static method. Yield is also static method. Okay, so there are some methods like start. There is method like set priority. There is a method like get ID, get name, get priority, get state, yield, join. Okay, these are all comes under methods. Methods of which class? Thread class. Methods of thread class. Thread class contains multiple methods. Out of them, these are the useful methods. Okay, and one more thing. Each thread has a priority. I repeat, every thread has a priority. Priority is a hint to the scheduler. A thread priority is a hint to the scheduler that this thread has high priority. So that scheduler can allocate the first chance for that thread. Of course, it may be or may not be, that we don't know. It depends on the scheduler. But we can set the priority. For example, what I'm saying is, see, this is runnable stage. For example, this is runnable stage. What I'm saying is, for example, this is runnable stage. Runnable stage. For example, this is runnable stage. And for example, this is running stage. And we know that a thread is moved from runnable stage to running stage. Who will take care of this work is scheduler. But in runnable, there are threads. T1 is in the runnable stage. T2 is in runnable stage. T3 is in runnable stage. Now scheduler has to pick up 1 out of 3. Scheduler has to pick up 1 out of 3. 3 are in the runnable stage now. 3 are in the runnable stage. Scheduler has to pick up 1 out of 3. For example, first thread has priority 7. Second thread has priority 5. Third thread has priority 1. A high priority thread is T1. So there is a chance that the scheduler may pick up first T1. For example, if the second thread has priority of 10, then there is a chance that scheduler may pick up first T2. It's not guarantee, but okay. Chance is there because of it has high priority. T3 has low priority. Like that, a thread can have a priority. Okay, the priority of a thread may be used by scheduler to first give chance to that thread. For example, if T2 has 10 high priority, then this scheduler will pick up T2 and will move that T2 from runnable state to running stage. Now, who entered into running stage is T2. It's not guarantee, but most of the processors or schedulers will do the work like this. Okay, it depends on scheduler also, operating system, scheduler and all. But chance is there because T2 has high priority. Like this, we can set the priority for a thread. And when you're setting the priority for a thread, the priority range can be in between 1 to 10. A thread cannot have more than 10 priority or less than 1 priority. In between 1 to 10. 1 is called as normal priority. It is normal priority. 5 is, sorry, not 1. 1 is called as minimum priority. 5 is called as normal priority. 10 is called as max priority. Maximum priority. By default, every thread contains 5 priority, nothing but normal priority by default. By default, a thread contains normal priority, that is 5. Minimum priority can be set is 1. Maximum priority can be set is 10. In between 1 to 10. If you set priority more than 10, something like 11, or if you set 0, for example, you will get exception. Okay. And for a thread, you need to set the priority before we start the thread. After starting the thread, we cannot set the priority. For example, I'm writing T1 dot start. Then I'm saying T1 dot, there is a method called set priority. Set priority of 8. There is no use. There is no use of setting the priority. Priority will not be considered because already thread is started, enter into runnable. So before calling start method only, what you need to set priority means how to write the code. First, T1 dot set priority of 8. Then I said T1 dot start. For example, another thread is also there. Then T2 dot set priority like this. Set priority of, for example, 4. Then T2 dot start like this. So when should I set the priority? Before start method is called. After calling start method, if you set the priority, no use. You will not get exception, but there is no use of this priority. It won't be considered. So priority must be set before we start the thread only, not after starting the thread. In thread class, to represent the minimum priority of a thread, there is a variable given called as min underscore priority in uppercase letters. This is static final. There is a variable given called as min underscore priority in the thread class. To represent a minimum priority is 1. The maximum priority, to represent a maximum priority, there is a variable given called as max underscore priority. Thread has this. To represent normal priority, norm underscore priority. These are the variables defined in the thread class. These are representing minimum priority, maximum priority, and normal priority. The 3 variables are defined. Value of minimum priority is 1. Max priority is 10. Normal priority is 5. Normal priority is 5. Okay, three variables are given. Let's see all of them. Let's understand all of them. Let's see. Let's go to thread class. You see the three variables here. They are static variables. There is max priority, the maximum priority that a thread can have. This is a variable called max priority. It is a static final variable. That's why it is in uppercase. Final variable means fixed. We cannot change the value like a constant in Java. How can you define constants in Java? By using static and final. Okay, final, if a variable is a constant, then we write in uppercase letters. Static final variables are called constants in Java. Class level constants. Max priority. What's the value of max priority? 10. 10. Norm priority. What's the value of norm priority? 5. Min priority, that is 1. There are variables given. In thread class, 3 variables are given. There are 3 variables defined in thread class. They are static final variables. One is min priority, norm priority, max priority. How can you set a priority to the thread like 5 or 6 or 7 or 8? There is a method called as set priority. And how can you know the priority of a thread? By calling the method called as get priority. There is a method called as set priority. There is a method called as get priority. So you can see get priority. Returns the thread's priority. That's called get priority. Similarly, there is a method called as set priority. Set priority method used to change the priority of the thread. By default, every thread contains normal priority. That is 5. If you want to change the priority, then call which method? Set priority. Okay, so first I wanted all these points for you, otherwise you will forget. Otherwise you will forget. First I will write all these points. Now we are talking about thread priority. Now we are discussing about thread priority. Okay. First, each thread has a priority. By default, the default priority of a thread is 5. The default priority of a thread is 5. Priority. Okay, the default priority of a thread is 5. Okay, thread priority is an integer value. So thread priority is an integer value between 1 to 10. Is an integer value between 1 to 10. The default priority of a thread is 5. I told yesterday, even main is also one thread. Every Java program contains at least one thread that is called main thread. Okay, even though it is main thread, its default priority is 5. For any thread, the default priority is 5. Okay, right? Every Java program contains at least one thread that is called main thread. If you create a thread class by extending thread or implementing runnable, then your program contains multiple threads. If you don't create any threads explicitly, then by default, your program has one thread that is called main thread. So every Java program contains one main thread. Whether it is a main thread or any other thread, the default priority is 5. 5 is called default priority. Okay. Now, in thread class, 3 static final, which are called constant. 3 static final variables are defined. To denote the thread priorities. To denote the thread priorities. I'll give you the variables names. One is min underscore priority. Min underscore priority. What the value of this? Its value is 1. Second one is norm underscore priority. What the value of it? Its value is 5. There is max underscore priority. Its value is 10. Its value is 10. Okay. Norm priority value 5. Max priority value 10. Minimum priority value 1. Like the 3 variables are given. Now, again, the point is what? Now, for example, if you want to set the priority for a thread, you can set or you can change the priority of a thread, because by default priority of a thread is 5 now. If you want to change the priority of a thread, then call set priority method. Example T1 dot set priority of 8. 5 is normal. I want to change to 8. Okay, right. That is, for example, I'm talking. For example, we can set like this. T1 dot set priority of 8. Okay, now. Okay, that's a way of setting the priority. It will be between 1 to 10. Okay, you can retrieve the priority of a thread. By calling get priority method. Okay, by calling which method? Get priority. Set priority method is to change the priority. Get priority method is to retrieve the priority. If you want to know what is the priority of a thread, then you can call get priority. Priority is the indication. A thread priority is an indication to the scheduler. Okay, is an indication to the scheduler that which thread should or which thread should be entered into running state. Which thread should enter into running state first. But of course, it's an indication only. But scheduler may follow it or may not follow it. That depends on many reasons. It's an indication that which thread should enter into running state first, whether T1 or T2 or T3 based on priority. A thread with high priority will have a high chance to enter into running state first. Its execution starts first. But it's not mandatory. Maybe or may not be, that we don't know. That depends on scheduler. That's an indication. Okay, right. That's an indication. Next step. One more point is what, before we conclude the class, I cannot set the priority after starting the thread. Okay. If you change the priority, of a thread after start method, what happens? After start is called, then the priority will not be changed. So when can we change the priority? We have to change the priority before what method is called? Before start method is called. Okay. Example I'm writing T1 dot start. Then I'm writing T1 dot set priority. Will it work? Priority of, for example, 10. Will it work? No. This priority changed or not changed? Priority is not changed. Priority not changed. Why? Because you are calling the set priority after start method. After start method. Now, another example. T1 dot set priority of 10. Then I say T1 dot start. Now the priority will be changed. Here I write a comment, priority changed. Priority changed. Okay, this is what we have discussed so far. Okay, how can we get the priority of a thread? By calling which method? Get priority, which returns integer value. If you want to get the priority, then you can call T1 dot get priority. Get priority returns priority. It may be 1 or 5 or 10 or 7 or 8. What happens if you write, for example, one more example I'm writing before I conclude the class. T1 dot set priority of 12. What happens now? Exception. This is called what? Exception. I will show you the exception. For example, I have a thread program already. Let's open the same program what I copied to you in the notes. Here only, can I set the priority here? T1 dot set priority of 12. What the range of the priority? 1 to 10. Between 1 to 10. But I am setting what? 12. I got exception. What's the exception? Illegal argument exception. Illegal argument exception. If I set, for example, minus or 0, at least 0, not minus, 0 also. Again, same exception. Illegal argument exception. Illegal argument exception. Am I clear? Okay. Priority can be between what and what? 1 to 10. For example, 4 I am setting. 4 is okay. 4 is okay. My program will execute. My program will execute. No exception. My program will execute. Am I clear now? Okay, I'm terminating the program. Just I want to write one message saying that what? Exception. What is the exception? Illegal argument exception. Illegal argument exception. Okay. Illegal argument exception. Okay. What about T1 dot set priority of 0? Same. What exception? Illegal argument exception. Illegal argument exception. So what is the range of the priority? Priority range could be in between 1 to 10. 1 to 10. Okay. 1 to 10. Minimum is 1. Normal is 5. By default, every thread has how much priority? 5. Max priority can be 10. 1 should be minimum. And you cannot give more than 10 or you cannot set less than 1. We'll get exception. What exception? Illegal argument exception. Okay, that's what we discussed today. Okay, I will share this document notes. Please go through it once. Today, multiple things we have discussed. And further, we will continue tomorrow. Okay, now tomorrow we'll discuss about more things on multi-threading. Clear? That's for today. We'll continue tomorrow. Okay, thank you.
Thank you, sir.